Good morning, everyone. I'm Rahul Ashok, the Business Development Manager at GenesInk, and I cordially welcome you all to today's webinar presented by Rita and I on next generation of advanced nanomaterials for IoT and 5G connectivity. GenesInk was created in 2010, employing about 23 people as of today, with a global team at your service. Our headquarters is based in south of France at Rousset, and we have sales offices in Paris, Taiwan, Tokyo, and we have representatives in the United States and China. We design nano-inks with functionalities at the core, from particle synthesis to the end printed product. And we also help companies to free up electronics to enable a new generation of consumer electronic products. Let's now have a look at some of the challenges and problems faced in the consumer electronic industry. There's a common misconception in the industry that nano inks are not available, not reliable at industrial scale, and is for lab scale production. Well, this is not true. Then the new consumer electronic product designs are also becoming smaller, and they tend to have more complex form factors that require smaller and more flexible electronics. And many consumer electronic applications today require high conductivity, which is critical. And finally, the production of PCB circuits have been both environmental and operator unfriendly. So now let's have a look at how GenesInk resolved some of these challenges and problems faced in the industry today. Well, we have proved everyone wrong, and we produce up to 1 ton of nano inks per year, and we already must produce inks to some of our clients. Our know-how has permitted us to design our inks with combined mechanical and optional functionalities, which end of the day provide flexibility, stretchability, transparency, and thinness. Well, this permits you to create the electronic device in a more smaller and complex form factor. And as consumer electronics requires high conductivity, we have developed ultra power efficient conductive nano inks, which is 5 times more conductive than the market leaders today. And finally, to tackle the environmental and operator unfriendly issue, we have developed inks that are non-CMR, which are ready to use, and they're easy to process inks. Well, GenesInk as of today has 40 nano ink solutions off the shelf that are readily available, and we also have 3 product families. Smart inks are a range of highly conductive nano silver inks, and then we have conductive, which is our transparent conductive ink range based on silver nanowires. And finally, we have Helios inks, which are a semiconductor ink range based on zinc oxide, aluminum zinc oxide, and tungsten oxide. And apart from that, we also have 60 plus patents filed worldwide and 12 patent families. Let's quickly have a look at our team. We have Rita and Victor, 2 R&D project managers at GenesInk. They both are PhD holders in chemistry and printed electronics, respectively. In the customer team, we are 3 of us in total. So Benjamin is our customer pre-sales manager, and we have Gregoire Stalins, who's our technical applications engineer, and myself as a business development manager. Well, before we start with the webinar, let's have a look at the agenda for today's webinar. I will be giving you a brief and a quick introduction of IoT and 5G to start off with, and we'll see if 5G is a game changer for IoT or not. Then a quick look at the market, and then my colleague Rita Fadul will take over, and she will be discussing more on GenesInk solutions that solve various challenges encountered in IoT and 5G. And then we'll move on to conclusions. And after conclusion, we will be distributing polls to have feedback on today's webinar. And finally, we would end today's session with a question and answer session. And yes, and I also forgot to mention during the webinar, if you have any questions, on the left-hand side, there's a chat box where you could post your questions, and we'll be happy to answer them at the very end. Okay, so let's start this webinar with a quick introduction of IoT and 5G connectivity. Okay, so I'm going to give you a simple non-technical explanation of IoT. Okay, so how are you watching this webinar right now? It might be on desktop, on mobile, maybe a tablet, but whatever device you're using is most likely connected to the internet. And internet connection is a wonderful thing, right? It gives us all sort of benefits that just weren't possible before. And if you're old enough, think of your cell phone before it was a smartphone. You could call and you could text, sure. But now you could read any books, watch any movies, or listen to any songs, all in the palm of your hands. The point here is that connecting things to the internet yields many amazing benefits. We have seen all these benefits with our smartphones, laptops, and tablets, but this is true for everything else too. IoT is a simple concept. It means taking all the physical places and things in the world and connecting them to the internet. Well, moving on to 5G. 5G, on the other hand, is the fifth generation mobile network. It is a new global wireless standard after 1G, 2G, 3G, and 4G networks. 5G enables a new kind of network that is designed to connect virtually everyone and everything together, including machines, objects, and devices. 5G wireless technology is meant to deliver higher multi-Gbps peak data speeds, ultra-low latency, more reliability, massive network capacity, increased availability, and more uniform user experience to more users. Higher performance and improved efficiency empower new user experiences and connect new industries. So, is 5G a game changer for IoT? Well, let's have a look. There are a number of ways in which 5G will be a game changer for Internet of Things going forward. Well, the increase in the number of connected devices will allow for many more sensors to be deployed in smart cities and buildings. And today, the smart city sensors are generally limited. They are put on lampposts and cover the area very thickly or densely. For better or worse, 5G allows for saturation of an area with small sensors. This allows for users that range from detecting pedestrian movements to turn on lighting. With current systems, it's impossible to have it's possible to have issues with the light failing to detect a stationary person and going back off. And if you see inside buildings, we have Bluetooth technology, which is already creating the ability to track people, vehicles, and equipments. 5G, however, will allow for transmission of a lot more data with IoT. Then moving on, imagine how a smart city with thousands of cameras could guide people around traffic accidents, or let's say tell people where there are places to park. Well, on top of that, autonomous vehicles will soon begin to take off, and 5G networking will allow 5G networking with IoT will allow cars to talk to each other and the environment, which reduces the risk of accidents and allowing far more efficient traffic patterns. Then moving on to telehealth. Telehealth right now is subject to the potential of blackouts and to poor connectivity for those most in need of it. Those in rural areas where a doctor may be an hour-long drive away, 5G will increase internet speeds in remote areas and may allow for such things as specialist surgeons working, let's say, via a robot in rural clinics, small clinics, yeah. It will also allow for people with contagious diseases to be diagnosed remotely without having to come into hospitals and spread the disease around. And when you have a look at retail, imagine walking into a store and having your phone, or let's say better is your AR glasses, tell you where the item is that you're looking for. Or let's say imagine you can look at your dress and the gear will pull up a picture of how it will look on you using a virtual reality. Well, smart tags and digital signage will allow for a much smoother and much more better shopping experience. Then we'll see integrated supply chains. Factories and warehouses are already using real-time tracking for inventory control and to track parts, products, and equipments throughout the entire cycle, and thanks to IoT in manufacturing. 5G promises the ability to use the single system to, for example, track a product from manufacturing to the very end user. very easily without any need to check it in or check it out. And with the vendor being alerted when the product is being delivered. And then finally, when you see network slicing, this is one of the best things about 5G is the ability to implement virtual networks. These will create subnets that can have different traffic priorities. For example, let's say in a hospital, the network could be designed in such a way that ensures that the connection between the surgeon and the robot was prioritized over, let's say, for example, communications that was being used by the patient. So what is the conclusion from all this? The Internet of Things is going to transform our lives over the next few years. And 5G, as it slowly rolls out, is going to enable much more far-reaching connectivity. Our cities will get smarter, our cars will also get smarter, and our packages will tell us when they arrive on our doorsteps. And finally, let's have a quick look at the 5G and IoT market. The 5G IoT market is expected to grow from $0.7 billion in 2020 to $6.3 billion in 2025. At a compound annual growth rate of 55.4% during the forecasted period. Factors such as low latency connectivity, increasing number of connected IoT devices, and growing data traffic are driving the 5G IoT market as of today. Market research studies show that North America is expected to hold the largest 5G IoT market share during the forecasted period, followed by Europe and then Asia Pacific. Well, could the COVID-19 situation change the scenario? Well, it is predicted that it could. There are new studies that predict North America will remain in top with the highest market share, followed by Asia Pacific and then Europe. Well, the reason for Asia Pacific to take over Europe is mainly due to the fact that they are expected to have high growth in 5G IoT market due to the presence of large number of electronic manufacturers in the region. And they haven't been impacted as much as Europe with the COVID as well. So that could be another reason as well. And finally, let's have a look at some of the major players in the industry. Some of the major players are Huawei, Samsung, Ericsson, Qualcomm, Intel, Corning, and HP. And finally, my colleague Rita Fadul will take forward from here, and she'll be explaining to you the different challenges faced and the GenesInk solution.
Thank you, Raul, for the introduction. Good morning, everybody. So let's talk about the challenges and of IoT and 5G and the solutions proposed by GenesInk. So who says new technology says new materials and then new processes and tools to process the new materials and the new materials. Furthermore, the second challenge is the dimension of the devices and components for 5G. Indeed, 5G needs higher energies, high energies, so bigger batteries and devices must be used. And furthermore, a new communication network must be deployed and new infrastructures implemented. This may have an impact on the environment. Concerning the frequency band for 5G, high frequencies are needed all the way up to 300 gigahertz. And with high frequencies, we will have more interference between the things, between the devices and the components. That's why we will need solutions of shielding to protect the things from EMI. So how GenesInk is responding to IoT challenges? Our materials can be processed and adapted to various application and processing methods. So that's why our customers and our partners do not need to invest in new processes or tools to process our materials. They can use their existing processes. Concerning the miniaturization, with our nano-inks, you can go very high in resolution, very low, so in line width. For example, here in this photo, you can see our ink processed by Porsche Institute, and we have 129 nanometer in resolution. This was processed by nano-imprint lithography on smart ink flexography ink. Furthermore, with very low thicknesses, as low as 150 nanometers, we can have very high conductivities with our smart ink range. Concerning the frequency bands, our smart ink range is adapted and can be adapted for all type of antennas, frequencies, and designs. For the moment, our smart ink range was already tested in RFID, NFC, 4G, Wi-Fi, and cellular antennas. And for electromagnetic interference, we have very high conductivity inks that can be processed by spray printing for full layer printing, and it allows EMI shielding. So our smart ink range can be applied to various applications in IoT and 5G connectivity, such as antennas and sensors, stretchable and wearable electronics, in-mold electronics, and EMI shielding. This range of material is compatible with various types of substrates, flexible, stretchable, and rigid substrates, such as polymers, paper, cellulose, glass, composite, and silicon. The second point we are going to talk about today is display in IoT. For display, we'll focus on transparent conductive electrodes challenges. The material used today and conventionally for transparent conductive electrode is indium tin oxide. And indium is known to be a scarce material in its way of depletion. It lacks of flexibility, and it is deposited by very heavy deposition methods such as chemical vapor deposition and physical vapor deposition. And to respond to these issues with ITO, new materials are being developed on the market as alternative to ITO, but with these materials we have very limited dispersibility, lack of homogeneity, and lack of stability. So to answer these challenges, GenesInk introduced conductive range for slot die and spray printing. This range of materials is based on silver nanowires. It can allow to reach very high transparencies, as high as 90% with very low hazes, and in the same time have very high conductivities as low as 5 ohm per square. The film deposited with silver nanowires have high flexibility and high resistance to bending. They have very high adhesion to polymers and cellulose substrates, and very high dispersibility in common chemicals, and they are easy to process and allow to have homogeneous films when deposited. And for the moment, we have 2 new inks under development at GenesInk for conductive, for flexography, and for screen printing ink. So to conclude, today at GenesInk, we create new functionalities such as flexibility, transparency, high stability, stretchability, optimized processability, and high conductivity to meet the requirements of consumer electronics market of today. Our nanomaterials can reach a very wide range of applications such as IoT, lighting, health, energy, and smart packaging. So now we will have the post session with Raul.
Yes, thank you, Rita. So yes, that would be the end of the webinar for today. But however, before we move to the question and answer session, I will be sending out the polls right now. So the first poll would be, how interesting was the webinar? Okay, moving on. Are you currently facing roadblocks in your IoT development? Okay. Next question would be, would you be interested by it? Okay. The final question. What are your sector of interest? All right. Okay, I'm sorry. I just realized that I missed out one question, I suppose. Yes, one last question, yes. By which range of GenesInk products are you interested? Just to give you a heads up, SmartInk is our range of nano-silver inks. Conductive is our transparent conductive ink solution. And Helios is a semiconductive ink solution based on ZNO, aluminum zinc oxide, and tungsten oxide. Okay, so we're done with the survey, and now we'll move on to the question and answer session. If you have any questions, please feel free to type them on the chat box on your left-hand side, and we would answer them to you right away. But as of now, we don't have any questions, and I assume that, okay, no worries. We'll give you some time to think about the questions if at all you have any. Okay, so we have the first question. What are the sheet-resistant ranges for your transparent conductive ink?
Yeah. So for our transparent conductive inks, for 90% sheet resistance, we can have transparencies as high as 90%. For 90% transparencies, we have sheet resistance of 10 to 15 ohm per square. And for 5 ohm per square sheet resistance, we have 75 to 80% transparency.
Okay, so next question. Can you please confirm the maximum ink stretchability?
We have done tests up to an elongation of 30% without any change of the conductivity over 50 cycles.
Okay, the next question. How is the stability of the inks? Well, this is a very broad question. So, yeah, I'll let you answer, Rita.
Yeah. For Smart Ink, we have a minimum stability of 6 months, and it can go up to 1 year, 6 months. So yeah. And for conductive inks, the stability is about 3 months.
Okay, and I would like to add to what Rita said. We do have clients who are still successfully, who have successfully used the inks even after 1 year period and never faced issues with the stability. And I'm referring to the nano silver inks. Yeah. Okay, so next question. Name and contact info for the North American rep company. So our representative in the United States is NTV, and I could answer this question right away by giving you their email address. Okay, the next question. What is the conductivity range of the inks?
Yeah, for Smart Ink, in resistivity, we can go down to 4 micron centimeter, and for conductive, we have the sheet resistances is between 5 to 50 ohm per square. It will depend on the thickness of the deposited layer, and for the thickness, we are around 150 nanometer, 100 nanometer to 400, 500 nanometers.
Okay, next question. What substrate material are compatible with your stretchable inks?
Thermoplastic materials such as TPU materials, polymers, and polycarbonates were tested for the moment, and they are working. Our inks works very well with these types of substrates.
Okay. Do we have any more questions? No, I think we are done with all the questions. And okay, so should you have any more questions, do not hesitate to reach out to us, and we would be happy to answer them to you. All right. I thank you all for today's participation in today's webinar, and I hope it was useful for you. Thank you.
Thank you all. Bye.